Hi students, this is Mr. Yao. Let's continue on 4.16b. This is the last few examples, and let me specifically talk about these. Before we get started into these problems, let me remind you about how the parent function of quadratic look again. It is a parabola and looks like this. That's not the only thing. Something else is, these are the points we typically have. We have the vertex starting from 0, 0. And then to get to the next point is 1 right, 1 up. To get to the next point is 2 right, 4 up. Left, same, 1 left, 1 up, or 2 left, 4 up. That's how we get to the point without any changes. So we're going to keep that in mind when we try to decide about the stretch and shrink based on a function graph given. So let's have a look at example 7. If you look at this is my vertical point, the vertex, and it is 1 to the right, 1 to the right, 1 up, 1 to the left, 1 up, 2 to the right, 4 up, 2 to the left, 4 up. That means there is no stretch or shrink whatsoever, because there's the kind of basic setup didn't change compared to the parent function. So the only thing that happened to this problem, let me actually write it in a different place. There is no stretch or shrink. So the only thing that actually happened to this question would be moved 2 to the left and 4 up. So shift 2 right, then 4 up. And you should easily be able to write the function based on that information. F of x equals, the x squared doesn't change, 2 to the right. That means I'm going to need to have x minus 2, then squared. 2 to the right, horizontal is the opposite, so it's minus 2. Then 4 up is a plus 4 on the end. That's example 7. Next, since we have said horizontal is always the opposite, so you kind of need to keep that in mind if you want to think it as horizontal stretch or shrink. But if you think about it, a horizontal, well, if you actually stretch something vertically, like getting into this shape, that's a vertical stretch. It is the same as having this graph, but I'm actually doing a horizontal shrink. So they kind of work the same way, which is why if you want to make your life easier, try to avoid thinking it horizontally, because you always need to keep in the back of your head that is the opposite. Instead, always think what changed vertically. So for example, on this example, in example 8, my first point is here. When I want to think what changed vertically, I'm always going to go 1 left or 1 right, and then just see what changed from going 1 up to. So in this case, it's going up this much, which, yes, is not super clear, but that you can estimate to be 1/4 or 0.25. So this is actually going 1 left or 1 right, but it's going 1/4 up. So that is going to be a vertical shrink by 1/4. And if you think about it, I can also think it as, oh, it's actually going 2 to the left, then 1 up. So that means the vertical didn't change and horizontal is actually changed by 2. But horizontal is always the opposite, so instead of multiplying by 2, it's actually a 1/2 x. And if you do that, it's the same as having a 1/4 outside. Because it's 1/2 squared, it's going to be a 1/4 outside the square. So either way, they work the same way. But the vertical one will make your life easier. So let's always focus on the vertical one, which again means you're always just going 1 left, 1 right, see what the y is going to be. See what's going to change vertically. And besides that, there's more change to this one. It also moved 1 left and 1 down. So it's shift 1 left, 1 down. So let's have a look. My final answer is going to be f of x. 1/4 is outside the function. 1 left, so x plus 1, then squared. 1 down is minus 1. Now let's see example 9. Similar idea. Always go 1 left or 1 right, and you can see it's actually going 2 up. That means it's going to be a vertical stretch by 2. And then that's not the only thing. It also moved 1 to the right and 2 down. So shift 1 right, 2 down. So my final answer, f of x equals the 2 in the front outside the function. 1 right is x minus 1, then squared. And then the 2 down is minus 2 on the end. That is example 9. Now let's still do 2 more, since these are all facing up. I know the other question is not on your notes, but let's just do 2 more that are facing down. So first, same idea, we need to just go 1 left or 1 right and see what's there. It's also going down by 1/2. So in this case, it's going to be a vertical shrink by 1/2. That's not the only thing, it's also vertical flip over x-axis. Remember, you're always comparing this graph to like the parent function. So clearly, without the shift anymore, or without the shift is actually facing down, so there is going to be a flip over the x-axis. And then we can check what is the shift. That is actually moving 4 to the right, then 1 up. So it's going to be shift 4 right, 1 up. We can base on these information to write our function. F of x is 1/2 in the front outside the function, outside the square. Then flip as a negative sign in the front. Then inside parentheses, it is 4 right. It is 4 right. So I'm going to, let me fix that, it's 4 right. So that means I'm going to subtract 4, then square, is 1 out. So I have a plus 1 on the end. Now the second one, let's have a look. First, so 1 left or 1 right. That you can see is actually going to be 4 down. So when we go horizontal, it doesn't change. Vertically, it changed from 1 to 4. So it's going to be a vertical stretch by 4. Then we have more. Clearly, it was here and now it's facing down. So there's a vertical flip over the x-axis. And then we have lastly the shift. It's 2 to the right, then 3 up. So shift 2 right, 3 up. Let's write the final function f of x. Stretch by 4, so 4 in the front outside the parentheses. And it's a vertical flip, so negative sign in the front. And then it is 2 to the right, so x to the right is minus 2. Don't forget a square. 3 up plus 3. That's the final answer for that. And now that concludes everything for 4.16. Thank you.